So here's the first part of the review for the test. Now, if you look at the questions that I handed out, they're available on Moodle as well. So before you watch this first little bit, why don't you look at the first two questions and see what answers you can come up with. Maybe pause the recording while you do it. It's always a lot better to think it through yourself than just listen to me explain things, I think. So on a test review, have a look at those first two, pause the recording, and then come up with your own answers and pick them, and then we'll go over it. All right, so hopefully you've had a look at the first two questions and you've got some answers for them. Let's see what I got here, and let's see how that might work. All right. Now, the person who can lift water the highest in a straw would be the person on the beach, because the person on the beach is down at sea level, and sea level has more atmosphere above it, so it has a higher atmospheric pressure. So with a higher atmospheric pressure, that pressure would push water up higher into the vacuum in the straw. So that's why you could lift water higher down at the beach than you could at LBCC or up in the Himalayas. All right, now if you push down on that hydraulic jack, piston D will exert the most force, because the force is the pressure times the area. And the area of D is the largest of the three pistons. So that would have the largest force. The smallest piston would move the farthest, because the displacement of a certain amount of fluid would serve to move piston B higher than it would the other two, because this has the smallest area. So if you put a certain amount of fluid into each of these cylinders, B is the one that will go the highest. The fluid would push it up higher than it would the other two. Okay, so that's kind of what's going on there. So bigger area means more force, but it also means less displacement for a hydraulic jack. All right, and you might want to just work through the rest of the exam, just, or the sample problems, I should say, and just then after you've done that, have a look at the rest of this review. All right, so let's have a look at some of these others here. Okay, pressure in the pipe. The fluid has a specific gravity of 1.21, so 2.89 feet, 0.33 psi per foot. That's for water, so every foot gets you 0.433 psi, but then the specific gravity is 1.21, so that's factored up. So you factor up the 2.89 times the 0.433 by 1.21 and get a total pressure there of 1.51. Okay, this one is covered on the next video, so I just lost the beginning of the lecture, so I just redid those first three problems. So the next video should have all the rest.